parent functions. In this part, we will learn some parent functions, sometimes we call it basic functions, and we also want to study the piecewise functions. So the first parent function, which is called the linear function, linear function is actually given by f of x equals ax plus b, right? And we know that if f of x equals y, so it's y equals ax plus b, which we have learned this is called the linear equation, right? It represents a line. This is a line, a straight line, okay? So now let's look at one example to have a look at this linear function. This is called a linear function, okay? So we want to find a linear function, which is a line, right? Linear function for which f of 1 equals 3 and f of 4 equals 0. So since linear function represent a straight line, so we just needed to find a line equation, okay? We needed to find a line equation through the points, which 2 points? When x equals 1, f equals 3. So through the point 1, 3, when x equals 4, y equals 0, right? Through these 2 points, we know if we have 2 points, we can always find the equation, the line equation, right? So the first thing we need to do is to find the slope, right? Slope is y minus y, x minus x. Be sure the order should be matched, right? So 0 minus 3, 4 minus 1. So it becomes -1. So we pick an arbitrary point as our point slope form, right? So we pick the second point, for example, this time, y minus 0 equals -1 times x minus 4. So y equals -x plus 4. So this is our line equation, right? So what is the linear function? Linear function would be, we just replace linear function. When we talk about the function, we always like to use the f of x. So linear function, we replace y with f of x. F of x equals -x plus 4. So this is the linear function. Okay, linear function, you just replace y is just from the linear equation, then replace y with f of x. Right. Then we have, this is the linear equation, okay, a linear function. This is a very basic function or parent function. And the second one, which is called the constant function. Constant function, which is given by f of x equals b. No matter what x value, it's always b. So this is the one example. If b is here, so this is the horizontal line, right? This is the horizontal line. So from here, then we can see that the domain, which is from -infinity to infinity, we have no any restrictions on x, right? The range, which is just a point b, right? Number b, this is the range. So this is the constant function. Identity function, which is a special linear function. F of x equals x. This is called identity function. This is f of x equals x, or y equals x. So this function, which is Symmetrical with respect to the origin, right? This is the first. This is the order function. And this function, the domain, which is from negative infinity to infinity, right? The range, which is also from negative infinity to infinity. Which is called the square function. Square function is f of x equals x squared. The graph will look like this one. Okay? And this function is an even function. If you replace x with negative x, it will recover the original function. So it's an even function. It's symmetric with respect to the y-axis. And the domain, which is from the x values, you can plug in all the x values, right? Negative infinity to infinity. The range, because it's above the x-axis, so it's from 0. 0 is here, right? 0 to infinity. So this is the y values, right? Corresponding to these points on the curve. Cube function. Which is y equals x squared, x cubed. Or sometimes we say f of x equals, or f of x equals x cubed. Sorry. So the graph is this one. So from the graph, this is symmetric with respect to the origin. So this one would be order function, right? And the domain, all the x values you can plug in, right? All the x values you can plug into the equation. So this is from negative infinity to infinity. What is the range? Range is all the y values corresponding to the points on the curve. Look at the points on the curve correspond to all the y values. So this is the negative infinity to infinity again. 6. Absolute value function. Which is f of x equals the absolute value of x. Or sometimes we just say y equals f, right? These are the absolute value functions. So the graph will look like this one. Okay. So here it goes through the point 1, 1 point, 2, 2 point. And here is 1, negative 1 point, and negative 1, 1 point. This is the negative 2, 2 point. Okay. So this is it's symmetric, so this is an even function, symmetrical with respect to the y-axis. And the domain, all x values, right? The range, you can see from the graph, it's above 0, including 0, so it's from 0 to infinity. Seven, square root function. Square root function, f of x equals square root of x, or sometimes we say y equals square root of x. They are the same thing. The graph will be this one. Okay, and from here we can see that domain is from 0 to infinity, right? We cannot plug in negative numbers. The range is also from 0 to infinity from the graph, right? The range is here, right? The upper half y-axis, right? All the y values corresponding to it. There is a point corresponding to the y values. Eight, cube root function, which is f of x equals the cube root x. So this is this one. This is the order function, the first thing, because it's symmetrical with respect to the origin. And the domain, which is from negative infinity to infinity. The range is also from negative infinity to infinity. This is from the graph, right? All the y value corresponding to a point on the curve, and all the x values correspond to a point on the curve, right? 9. This is the reciprocal function, which is f of x equals 1 over x. So our graph will look like this one. Okay. So this is the order function again. And the domain. Domain is all the x values except 0, right? We cannot plug in 0. So it's from negative infinity to 0, union from 0 to positive infinity. What is the range? Range is all the y values. You can see all the y values. There are points correspond to. There are points for this y value. There are a point for this y value. There are a point for this y value. There is a point corresponds to it. There for this y value. There is a point for this y value. There is a point for this y value. There is a point, except this one. Right. So it's also from negative infinity to 0. Union 0 to infinity. All the y values, all the y except the origin. So these basic functions or parent function are very important. You should know the properties and know the graph, especially the graph of these functions. Okay. So now let's look at the piecewise function. Roughly speaking, the piecewise function is a function that have several branches for different x values. In other words, for different x values, the expression of the function would be different. Now let's look at some examples. One example is f of x equals x plus 1 when x is greater than or equal to 0. If x is less than 0, it's equal to x minus 2. So be careful. For the different values of x, it will give you the different function. So now let's look at f of 0. So in other words, when x equals 0, what is the function? X equals 0, which one it belongs to? Which branch? The top branch or the lower branch? Of course, the top branch, right? Because here, the top branch says x could be greater than or equal to 0. So 0 is included in here. So it becomes 0 plus. So then we will take this one, x plus 1. So 0 plus 1 equals 1. F of 3. 3. X equals 3. Which one? It's greater than or equal to 0, right? So we still use this one. So 3 plus 1, which is equal to 4. F of negative 1. Negative 1 is less than 0. So we will take this one. Right? So it becomes negative 1 minus 2 is equal to negative 3. So for the different x values, then you will have the different function, right? Function expression. So now let's look at the graph. We are interested in, okay, let's look at the domain. Domain is, what's the domain? Domain, you just combine the branches, okay, the range of the branches. You combine the x values of each branches. So this is from greater than or equal to 0, less than 0. So that includes everything, right? Negative infinity to infinity. So now let's look at the graph for the function. So when x is less than 0, it's equal to x minus 2. So x minus 2 is this one. X minus 2 is this one, right? And here is negative 2. When x equals 0, it's equal to negative 2. But our range, our domain for x is from less than 0. Less than 0 is here, right? Is here. Here is less than 0. So we will take, of course, x minus 2, you can extend forever, right? You can extend forever. However, if it's only x less than 0, so we will not have this part. And x cannot be 0, so this point is a circle. It's a hollowed circle. So that represents x equals 0 on the, it's not on this line. Okay. If x is greater than or equal to 0, it will take the value x plus 1. X plus 1 is here. This is x plus 1. And x can be 0, could be 0, so this is solid point. This is solid point. So this is the y equals x plus 1. And this is the y equals x minus 2. This branch. So this is the graph for y equals this piecewise function. This is the graph for y equals f of x. F of x have the different values. X plus 1 when x greater than or equal to 0, x less than 0. Then it's equal to x minus 2. So this is the graph. So if we would need to find the range for a piecewise function, so you'd better to look at the graph. Okay, sketch the graph first. So sketch the graph so you can see the y values. Y values could be all the values below this negative 2, right? Because all the y values below this negative 2, there's a point on the curve. All the values, if this is a 1, right? X equals 0 equals 1. All the values above 1, there's a point on the curve corresponding to it. Okay, so the range of the y value is negative infinity to negative 2 is this part. Union and this part 1 to positive infinity, and the 1 should be included because this is a solid line. So between 1 and negative 2, there's no points on the curve corresponding to these y values. Okay, how to sketch the line? Straight line, you just pick arbitrary 2 points, right? You're using the way we test give some sample points to draw the line. And from the graph, we can also see is what is x-intercept. X-intercept, there's no x-intercept, right? Because there's no intersection point on the x-axis. What about the y-intercept? Y-intercept is only one point intersects the y-axis. This is a hollow circle. That means this point does not exist. So this is the y-intercept. So now let's look at another example. Okay, also from the domain, look at the domain of this from the graph. Then you can see all the x values. There's a point corresponding to it. For this x value, x equals 0, is this point. For this x values, 0 points on this curve, okay? So the domain is also from negative infinity to infinity. Square root x, x is greater than 0, x equals 0 equals 4. And x greater than equal to negative 3 less than 0, which is negative 2x. Okay, so let's draw the graph. So from negative 3, 1, 2, 3, okay, negative 3. It's negative 2x. Negative 2, 3 to 0. But 0 should not be included, right? 0 is a circle. We're starting from this point. When x equals negative 3, it's equal to 6, right? Then we say x equals 0 equals 4. So 1, 2, 3, and 4. This is 4. So this is a solid point. So that means when x equals 0, it's equal to 4. When x is greater than 0, it's equal to square root of x. Square root of x, we know the parent function, the square root of x, the curve, will look like this one, right? Will look like this, so you can draw the graph quickly. Greater than 0. So this is the curve. So from this one, okay, let's look at several problems. F of 0. F of 0 equals 4, right? X equals 0 equals 4. F of 1. Which branches? You have 3 branches. 1, 2, 3, right? 1 belongs to greater than 0, so it's equal to square root of 1, which is 1. F of negative 1. Negative 1. Negative 1 is less than 0, greater than negative 3, right? So it should be negative 2 times negative 2 times negative 1, so which is equal to 2. Then what is the x-intercept? There is no x-intercept. This point is a circle, hollowed circle, so this point does not exist. So there is no intersection on the x-intercept. So there is no x-intercept. Y-intercept. Is there any intersection point on the y-axis? Yes, this point is the y-intercept. So this is 0, 4 is the y-intercept. What is the domain? Domain from the graph, it's starting from this point. This point corresponds to negative 3. Then we can continue forever, right? So it's from negative 3 to 0. To infinity. We can also combine the x range for each part. It's from negative 3 to greater than 0 forever, right? So it's negative 3 to infinity. And the domain and the range. The range, we need to look at the graph. The range is the y values it can take, which is this 0 can be taken? No, this point does not exist. It's just a greater than 0, so greater than 0. Then other y value, there is a point corresponding to it.